Hello everybody, a very warm welcome to all of you in this webinar. So this is a webinar which talks about a brief about MongoDB, what is MongoDB, how we can use MongoDB. So in this particular webinar, we'll try to see that what MongoDB is and how we can make use of MongoDB to create a small use case. Okay, we'll try to see how we can do some data modeling using MongoDB. Before we go ahead and get started, let me introduce myself. My name is Rana, so I'm going to present this webinar to all of you. I come from a technical architect background with almost 11 years of total industry experience, and last 3.5 years I'm working with a lot of big data technologies, especially with MongoDB. So I implemented MongoDB in few projects which are already in production. So I want to just share my experience with all of you, and hope you will like it. So once again, very warm welcome to this free webinar. It's arranged by Edureka. So this talks about MongoDB development and a basic course of MongoDB. So just to ask all of you whether you can hear me good. I have got one responses from Kamesh. So if you can quickly send me a hi, hello, or whatever, so that you can hear me good. I know that everybody can. I'm audible. I'm reach out to everybody. Okay. Hi Amal, hi Rahul, hi Ramesh, hi Mohammad Asbar, Arvind, Sanjay, Sai, Deepak, Darshan, Lovikesh, Sashank, Amu, Sunil. So some of the names going pretty fast. So there are a lot of people, sir. They are already in the webinar session. So it's good to know that people are having a lot of interest to learn new things. So that's pretty good. So Chinna, I can see Manikanta, I can see Lakshmi Narayan, I can see Manish also, I can see. Okay, very good. Sugumar also I can see, very good. So yeah, I think I'm audible. So good. So we can quickly go ahead and get started, because it's just a 1 hour session. It will be little. We might need to be a little fast, and we might need to touch upon some basic concepts and see that how it goes. Okay, so let's go ahead. So these are the objectives to be covered in this particular session. So we'll see that what is exactly NoSQL Databases. We'll see what is a CAP theorem and how it fits into NoSQL arena. Okay. We'll try to see the introduction and architecture of MongoDB, how the deployment architecture of MongoDB, I should say like that. We'll quickly discuss about a couple of pretty interesting thing, which is called the CRUD Operations, which is nothing but the create, read, update, and delete operations. And then we'll see a demo use case. Okay, we'll try to practically implement a particular use case. And we'll try to develop some Java application and integration with MongoDB. That's what we probably want to see. So we'll mainly concentrate on the hands-on part, so that you people actually feel that how it's how it looks like in the ground reality, and the theoretical part we'll try to quickly cover it up. Okay, all set. So friends, right, when the moment we say about MongoDB or any persistent mechanism, right, we might want to know that, or we might want to recap that what exactly we have so far, right? So if you know, right, our journey started with the traditional RDBMS systems. Okay, so we have seen Oracle, MySQL, Microsoft SQL, DB-SQL, and other RDBMS database also, and which are nothing but called as online transaction processing. We have seen those databases are used in many of the applications like hospital management system, some insurance management system, okay, where user can go and do lot of online transactions, okay. So that's the main main part of RDBMS. And then also we have seen another type of persistent storage, which is called OLAP, or online analytical processing, mainly the data warehouse systems, okay, wherein we run a lot of offline batches, lot of offline transactions to come up with some of the business decision, okay, based on which business can take some decision and implement can track down the user behavior. So these are all the things that we generally used to have, right? So till the time 2004 2006 we are kind of good, but starting from 2005 2004 onwards, right, we have seen some challenges with the daily use cases. We have seen some new use cases are coming. We have started seeing some new applications are coming, kind of gaining popularity in terms of the applications where people go and store data for once, but they read them many times. So the behaviors is changing, the type of data are getting changed. So people used to save a lot of binary data, a lot of image data, video data, audio data, stuff like that. So along with the structured data, there are a lot of unstructured and semi-structured data people used to save and people wants to process basically. Also, we have started seeing that there are a lot of archivals of log files which were there in our storage system, but we never want to process those log files, right? So the problem comes when we have seen these challenges in terms of volume, in terms of velocity of the data, which is growing, correct? In terms of the veracity or variety of data, different types of data, we have started seeing those challenges, and we found that our traditional systems, our RDBMS systems, were not capable of handling these many aspects. Okay, so that was the main point when we started having when we started feeling some need of something different. Okay, so to think on those lines, what we have found out is that we did not have any problem to store the data, but the problem comes when you want to process those things, right? So that was the main issue actually. So we found challenging in terms of scaling out, because as far as RDBMS is concerned, maybe scaling up or vertical scalability is something that people still can do, but at the moment they want to scale out or distribute the data, right? There was an issue, there was a problem. I mean, I'm not saying it is impossible, but it's very difficult to possible. We actually needed some system which is very easy to scale out, which will give you provision to easy scale out, because we know vertical scaling has a limitation. Even if you want to increase your system resources, your processors, your memory, or stuff like that, right, there is a limitation beyond which you cannot go ahead, correct? So that to actually achieve elasticity, you need to scale out, you need to go for horizontal scaling. And at the moment we are talking about horizontal scaling, you need a system which will give you the ease of scaling out, number one. Number two, the moment you go for horizontal scaling, you are actually inviting other challenges. What are all the other challenges? The moment you are distributing the data, you have to increase your monitoring capability across all the systems, across all the nodes. You are actually introducing a lot of point of failures. Earlier you had only one point of failure, but the moment you have distributed it to 10 multiple systems, you are actually increasing your point of failures. So that means you need to have some backup mechanism. So stuff like that. So there are a lot of challenges coming in. NoSQL is a technology which is again come under that big data arena, right? So it gives you this kind of flavor. Number one, the bigger data handling capability. Obviously the volume, right? Volume was one of the major concern. The moment we are talking about volume, we saw that even if we do vertical scalability only one system, you go and simply store data. You can use SAN, but the problem is your IO. You cannot, your IO cannot scale up like the way you can actually scale up your memory or processor. So that's where the problem is. So to address that, what you need to do is you need to distribute, right? Elastic scaling. So this kind of a technology, any technology you take Cassandra, you take Neo4j, you take HDFS, you take MongoDB, Couchbase, any technology, it will give you elastic scaling, meaning you need the data, your volume is growing, you scale out. Say for example, your data volume is getting shrinked for some reason, maybe off peak hours or off peak season or whatever it may be, you want to scale down, you can scale down, no impact to your application. That's the advantage these technologies are giving. No schema and fixed data model. So especially MongoDB, right? Especially MongoDB, it's a database, it's a document database, which gives you a flavor of flexible schema. I should not say no schema, because you should have some definition of your data model, but the advantage of MongoDB is the flexibility of the data model. So it's a dynamic schema actually, and that is the behavior, or that is the use case a lot of people in the industry that use it today for MongoDB. So for example, whoever is going for MongoDB, they actually use this particular feature because it's pretty easy to develop application. It's pretty, your go-to market is very small. Okay, your go-to market is very fast actually. Okay, so that's one of the advantage. Integrated caching facility. Obviously, these databases, they do a lot of in-memory computations, right? So, and for these kind of applications, you might see that your memory requirement might be a little high when you are distributing it. Yeah, and that's how the caching thing is coming into picture. And obviously, the data complexity. So advantage, we are just talking about distributed architecture, fast reads. So satisfying write once and read many times. We have seen blogger applications. We have seen a lot of social networking sites where people write only one, and then there are a lot of people who go and read. So there was a need that my application is something like I can compromise with my write network or traffic, but it's kind of the read network traffic is very high. So that ask was very high. So like that. So I need a system where my read is very, efficient, right? So there are a lot of options to make your read very efficient. A lot of indexing options, a lot of distribution options, a lot of query caching options, stuffs are there. Easy replication, as I was talking about. So we know that vertical scaling will have some limitations. So maybe we need to go for horizontal scaling or scaling out. The moment we are, scaling out your data, that means you are inviting challenges. What kind of challenges? You are inviting multiple point of failures. To avoid that, you need to have a proper backup mechanism, correct? So proper backup mechanism, can you do it manually? No, you cannot, because let's say for example you are maintaining 1,000 node cluster or some 500 node cluster, right? You cannot go ahead and manually take backup. So the system or the persistent architecture, the technology that you are actually opting for, they should give you some automated way of replication. That means your backup of the data. Not only automated way of replication, they should also give you automated failover solution. That means, say for example, one of your node goes down, then your then there should be some backup node which should come up automatically, right? You cannot go ahead and manually do that, because your downtime, there will be a lot of downtime, right? So your technology should give that particular facility. Schema free, again we have already discussed, and higher performance. Now the moment we are talking about these many advantages, right, there was I'll just pause for a minute and I'll just reiterate this. The moment we are seeing a lot of advantages in terms of read preferences, in terms of read traffic, read performance and stuff like that, but also I should say that there were some architectural decision to do some kind of compromisation, especially for MongoDB. So what are all those architectural decisions? The two main compromisation which has been adopted in MongoDB is there is no joins supported across multiple tables. In case of MongoDB, we call it collections, but let's call it tables for the time being. So there are no joins supported, number one. Number two, no full ACID transaction supported. The moment we say ACID transactions, we know what is ACID transaction is: atomicity, consistency, in isolation, and durability. So any transaction happens in your RDBMS world, it should support these 4 characteristics, right? But MongoDB or most of the NoSQL database, there are some NoSQL databases coming up which they are claiming that they are kind of try to give ACID transactions, but I'm not talking about that today. We're mainly focusing on MongoDB. MongoDB does not support full ACID transactions. Okay, so again, somebody is asking that how to use primary key, foreign key. Yes, there is no primary key, foreign key. There is no foreign key concept. Obviously, there is a primary key concept, but there is no foreign key concept, as there is no join, because the way we actually do a data model design in case of MongoDB is totally different. Okay, initially when you start thinking about it, you might feel it awkward. Okay, if there is no relation, if there is no foreign key, right, how can I go ahead and do a data model? How can I design a data model at all if there is no relationships? Yes, we can. I mean, it's a different paradigm. We'll discuss about it. We'll take a small use case and we'll try to see how the data model can be done. Okay. Okay, so somebody's asking what is a ORM layer. Yeah, I'm just coming to that. In next few slides, we'll see that no need of additional ORM layer. So, for example, friends, you probably have seen earlier that we have used object relationship mapping in terms of Hibernate, in terms of IBITIS, right? So there are a lot of ORM tool in the market. You used to use that earlier. Even today, also a lot of people use that in terms of performance gain. Correct? In order to have a performance gain. In case of these kind of technologies, right, there is no need of ORM layer. Your application directly talk to your database, and that layer itself is avoided. How we can quickly see that? Yes, somebody is asking that, Rahul is asking, indexing is present in MongoDB. Yes, Rahul. So MongoDB has got a very rich, indexing support. So in terms of geospatial capability, in terms of time to live capability, in terms of multi-key index, it's a pretty, unique concept of MongoDB. Say, for example, if you have a array kind of document, right? Array kind of field, right? You can create an index in MongoDB which is called multi-key index. It basically creates index on all the fields which is there in the array. So it's a pretty unique concept. Geospatial index, it's a pretty useful concept. I'll just come to that. Just pause for a second. I'll just come to that. Somebody's asking, Poonam Chand is asking how joins hamper performance. So Poonam, right? So the more you go and the more you write joins, the more you access multiple tables, okay, for one query, you are actually hampering performance, right? You are actually, what do you call, compromising with your read performance, right? So that's why. So that's how joins actually hamper performance. The more you have joins across multiple tables, you will have better performance. Okay, so let's go ahead. There are other questions also, so we'll simply we will take those questions, but let me go ahead first, okay? Because we need to cover a lot of stuffs in this 1 hour, right? So before going to this, just park your questions for some time. We'll have a question answer session, okay? So before going to discuss about MongoDB, right, I'll just try to introduce you one quick theorem called CAP theorem. As far as a distributed architecture is concerned, the moment you want to design a distributed architecture, there is a theorem called CAP theorem coming into picture. When we say CAP theorem, what are all these? It's actually talks about consistency, availability, and partitions tolerance. Consistency, I mean, your data has to be consistent, okay? Availability also, your node has to be available, okay? And partition tolerance. Partition tolerance means the system continues to function even if communication among the servers is unreliable. So that means how tolerant is your application or your technology is the moment you go for multiple partitions of your data. Okay. Now the actual theorem says that the moment you are trying to design a distributed architecture, any two of these three requirements can be achievable. All these three cannot be achievable at one time. Okay, once again. So CAP theorem said the moment you are going to design a distributed architecture, at any point of time you cannot achieve all three requirements: consistency, availability, and partition tolerance. You have to compromise on something. Okay, be it any technology, you take any technology, whether it is RDBMS, whether it is Cassandra, MongoDB, HDFS, any technology, you will see that there will be some compromisation somewhere. Okay, 100% of all these three might not be possible. Okay, so this diagram also you can see that where exactly MongoDB falls. So MongoDB HBase falls under consistency and partition tolerance. So as far as availability is concerned, there might be some challenges. Okay, so but there are also workarounds. I mean, though we say about as far as theorem we say like this, but there are a lot of options they give you actually as far as availability and stuffs are that. We'll see those things as well. So coming from this CAP theorem, what we actually say, all these NoSQL technologies, specifically MongoDB, it doesn't guarantee the full ACID transaction, but what it guarantees is a base transaction. What is base? It will tell you that it will be basically available. Okay, does guarantee availability in terms of CAP theorem. Somehow it will be basically available. Okay, soft state means it indicates that the state of the system may change over time even without any input. Okay, how do you say so without any input? How your state can change? Because for example, let's say you have some backup nodes, one is primary and one is secondary, right? So you send all your write operations to your primary node, and your secondary nodes, they are getting replicated from your primary node, right? If that happens like this, then what is happening is you are not sending any input to your secondary node, but still its state is changing like that. Eventually it will be consistent. So maybe at the moment you are sending some data, it might so happen that all the nodes in the cluster might not be in this full it's not consistent, maybe 100%, but eventually they will be consistent. Okay, that's what a base theorem means. Okay, pretty good example that when we say NoSQL databases, actually there are around 150 NoSQL databases in the market. Actually, it's even more than that. Even I don't know all the names of them, but yes, the popular ones you should know. Popular ones in the sense we should know about Cassandra, MongoDB, Neo4j, Memcached, CouchDB, okay, obviously HBase. So these are the all popular NoSQL databases which are actually there in the market. When we talk about RDBMS, we always see that the architecture of RDBMS is almost same across all the databases. Like it has got a row column structure, correct? A table, a row, column, like that. Primary key, foreign key, like that. But in case of NoSQL technologies, even they are different based on the architecture, based on the use cases. So those use cases are actually part of our actual session of actual course of MongoDB. I mean, due to the lack of time, we won't be able to discuss about all different types of NoSQL databases. But what I can tell you, I can just show you that what are all the major 4 categories. Okay, so these are the major 4 categories based on which all the NoSQL databases are distributed or divided. So there is something called key value store, there is something called columnar database, okay, document oriented database, and graph store. So MongoDB falls under document oriented database. Okay, how the use cases are there, how you will actually select a particular technology or a particular NoSQL database, that depends on your non-functional requirement, that depends on your use case, the primary use case that you are going to develop into your organization or into your in your applications. So those details I won't be able to cover there, so I'll just skip that part. But these are the major categories. Now, I was telling somebody that there is no need of a ORM layer. So, for example, if you think of this solution with a traditional database system, okay. So, if you see here, right? So, so I have a traditional RDBMS system. Maybe it is partitioned or whatever. You can think of 2 node, okay. And there are applications here. If we have a web application, and what we can have is we can have a caching layer. Now that caching layer may be your ORM layer itself, your object relationship mapping layer itself. People who has worked with ORM, they know that how it helps. So it basically gives you a flexibility or one abstraction over your relationship model, right, in terms of your object diagram or object structure. So that for each and every data, you might not have to go to your database. You can get it from your caching layer itself, from your memory itself, right? So that's a flexibility it gives you. So for example, this is what it kind of it looks like how we can develop using an RDBMS system, right? And we can see that how many transactions it can happen and stuff like that. But the similar application, if you design with a NoSQL database, so what we are saying is there is no need of caching layer. Number one, the NoSQL layer itself, it works as a caching layer. It has got a lot of caching mechanism. Not only that, it can have an elastic scale. Okay, so and the moment you are having elastic scale, it will give you a lot of provisions in terms of monitoring of those systems, in terms of graphing of the system, stuff like that, right? So this is the main advantage that you are going to get, and obviously you can see the performance benefits in terms of transaction per seconds and stuff like that. Okay, now coming to our very own MongoDB. So again, as I said, MongoDB it's an open source database, obviously. So most of the NoSQL databases today are open source, so it's pretty easy to start development with it, right? And installation is pretty easy, obviously. So it's an open source database developed by a company called Tengen. So the company who has actually developed or built this particular product is called Tengen. They were called Tengen. After their product MongoDB has become so popular, they have actually renamed their organization to MongoDB itself. So if you go there, right, if you go to www.mongodb.com, you will find the use cases, the customers, okay, and a lot of documentations, a lot of videos are available. So that is also good. So you can go and check those things out as well. It's an agile database that allows schemas to change quickly as a application evolve. This is a very important point, friends. So today, right, everybody is agile. Everybody, you cannot say that your requirement is frozen and day after tomorrow you will start your development and you'll never come back to your requirement and never change your design. No, you cannot say that, because every time your business analyst or your product manager is asking for some new functionality, some new feature, right, and for which there will be some need of your change of your data model. That's the advantage of MongoDB, that it gives you a very good flexibility of changing your data model very quickly with very less impact in your application. I should not say zero impact. That will be an ideal situation. I shouldn't say that, but it will be a very it will be a zero impact. The best part is there is no DDL concept. We have worked with data definition language, right? So in case of RDBMS, what generally happens is, if there is any data model change, there is a DBA guy, you send your DDL query, they will first approve it, they will first run it on your database, you then do your changes in your application, and then only you can go ahead and deploy it. So there is a dependency, but here there is no dependency. From your application layer itself, you can directly change and you can do everything. There is no need of running a DDL query separately altogether. So that's again a pretty good advantage of MongoDB. Again, it leverage in-memory computing. I was talking about that. Native replications and automated failover, again very important. As I was saying, right, it should give you a flexibility, it should give you a provision so that your failover can be automated. Okay, so if somebody in some node goes down, then there should be some other node which should be up automatically. Open source document storage, you have already talked about. What is a document? We'll see that. It's basically a JSON document. It's JSON formatted, JavaScript object notation format. So whenever you save something from your application layer, it will go into the database and get saved as a JSON format. Internally, when it actually gets saved in the file system, it gets saved in a BSON format, which is nothing but a binary formatted JSON. Okay. Object oriented, the reason as it is object oriented, it's pretty easier for the user to work with it. You know why? Because but we generally talk in terms of object-oriented language, right? We are pretty useful. We are pretty comfortable to talk on the object-oriented language. So if your data model directly is in proportion with your programming language or your application development language, right? It's pretty easy, right? You don't have to actually write any queries and stuff like that. Your Java code itself is something, or in your code itself, not Java, any other programming language code itself is something which you can work with. It's written in C++, and as it is written in C++, it is pretty lightweight. So you can, when you actually install MongoDB in your system, you will see that how lightweight, what is the memory utilization and processor utilization of that particular process itself. Easy to use, full index support. Somebody was asking this question, so it has got a very rich indexing support. Okay, so replication and high availability is the solution of MongoDB in terms of high availability. So replica set is the solution from MongoDB in terms of high availability. It says, it actually signifies a set of cluster or set of nodes, okay, wherein one node can be primary and other nodes can be secondary, okay, secondary or some other thing probably. Okay, the idea is if the primary goes down, so all read and write operations by default will go to the primary. The moment primary goes down, automatically there is a process called election, okay, by which some other secondary will be elected as a primary, and it will support all the read and write operations. So there will be very, very less downtime, maybe some 30 seconds downtime maybe. So that's the advantage, right? Because your data is distributed. The moment your data is distributed, you have multiple point of failure, correct? So you have to have some backup mechanism. You have to have some high availability mechanism. Okay, partitioning of the data, distribution of the data, scaling out of the data is done by auto sharding. Sharding means partitioning. You distribute your data, and the moment we say auto, right, automatically it will get distributed. So actually you don't have to do any distribution manually, node by node. What you do, you simply load the data and data gets distributed automatically. So if you look at this particular picture, right, the second picture, shard 1, shard 2, like this, right? So the moment you send some queries or data, okay, to your MongoDB or to this cluster, it will get distributed to all these different nodes. How it will be distributed, what are all the pros and cons, what are the ways, those everything is part of your detailed course of your MongoDB. Okay, easy query, it has got a very easy interface as well. And okay, a very important feature of MongoDB is MapReduce. Okay, we have gone through MapReduce in case of HDFS, in case of Hadoop, right? But MongoDB also got its own MapReduce framework. So it has also, I mean, the definition is same, the abstraction is same. You have got some map functions, you have got some reduce functions. Okay, so you can actually use those MapReduce functions on top of a large data set, right, to come up with some analytics results. GridFS is the solution from MongoDB to store the large files. For example, large files in terms of video files, in terms of audio files, stuff like that, right? Generally, we do it in case of RDBMS, we do it as a blob object, or maybe we save it as a file in file probably. But the problem is those are not distributed. Okay, that's the problem. But GridFS is a specification which gives you the provision, which gives you the flexibility to save these big objects, the binary objects, in distributed manner. Okay, so we do a lot of streaming data today, right? We do a lot of audio streaming, video streaming data today, right? So if it is not distributed at your storage application itself, there will be a very blockage of your IO. So that also it needs to be distributed as well. Okay, so let's quickly go ahead. Okay, a quick terminology between RDBMS and MongoDB. As I said, I'm not looking into the questions. I know there are a lot of questions going on. Just park your questions. There is a question answer round. Let me cover some of the slides and we'll take all the questions. Okay, maybe while discussing these concepts, maybe some of your questions might be answered automatically. So I request you, just to park for some time. Park your questions for some time. So some terminology between RDBMS and MongoDB. So in case of MongoDB, right, some of the terminology is a little bit different. Okay, so database in case of RDBMS is called as database here as well. So database is the, you know, least what should I say? Database is the unit of physical entity, right, where the data resides. Okay, the physical entity actually. Okay, table in case of RDBMS is called or is known as collection in case of MongoDB. So in MongoDB, we don't call it as tables. Whatever we used to call table in case of RDBMS, we call collection in case of MongoDB. All the tuples or rows, whatever we used to have in case of RDBMS, we call them as document. Okay, document is nothing but, once again, as I said, it's nothing but a JSON object, JavaScript object notation. Okay, a JSON formatted object. We'll see that in the hands-on, don't worry. And in case of RDBMS, we have column attribute variable, but in case of MongoDB, we have field. Okay, now the fifth point is very interesting. We say that in case of RDBMS, we have join, table joins. And also we mentioned that MongoDB does not support join. But what we mentioned, MongoDB does not support join across multiple collections, correct? So to avoid that, there is a feature called embedded document. So what MongoDB does is you have a parent child document kind of stuff. Instead of distributing those information into two different collections, what we do here is, in most of the cases, may not be in all the cases, but in most of the cases, what we do here is we have a parent document, like say for example class, and inside class you have a student information, stuff like that. Okay, in that class how many students are there, for example. It's a pretty simple example, but just to make you understand what exactly a child and parent document is. We'll see those things in our hands-on. Okay, so as far as primary key is concerned, MongoDB has a primary key, and for MongoDB, the primary key is _ID field. So we'll see that also. Okay, and it is a mandated primary key in case of MongoDB. So in case of RDBMS, we might have some tables which might not have any primary key. That is possible. We can create tables without a primary key in case of RDBMS, right? But here in case of MongoDB, it is not possible. Not only it is not possible, but also the _ID field is a mandated field. It's a registered field as primary key. You cannot declare any other field as primary key. Okay, that's how it is. And the processes are also mentioned. Okay. Okay, so this picture will, gives you some, idea about how the distribution or how the deployment is done in case of what do you call? In case of MongoDB deployment, right? So if you see all these boxes are called shared. Okay, shared 1, shared 2. Okay, and these are nothing but the nodes which has the actual data. Okay, how the data is getting distributed. The data is getting distributed across these shared 1, shared 2 till shared 6. This is called the MongoDB cluster. How we access this MongoDB cluster? We access this MongoDB cluster through a daemon process called MongoS. Okay, MongoS is a daemon process which gives you the flexibility in terms of what do you call a query routing flexibility, right? Your write operations or read operations will be routed through this MongoS. Okay, now to do that, what MongoDS does, it actually takes help of some configuration database, correct? So if you see, there are some configuration database here, right? So it takes help of this configuration database. What this configuration database do? These configuration databases, they actually hold the metadata of the distribution of the cluster. So that means it actually contains the data about the cluster in terms of where a particular data resides. Let's say you have 1 terabyte of data and you have distributed that 1 terabyte of data in 10 distributions. So 1 to 100 GB, 101 to 200 GB, like that you have distributed, for example. Now configuration database has the information that how that distribution happened, which node contains which data, stuff like that. Okay, so once again, how the deployment is done of MongoDB. MongoDB has got a large amount of cluster which is called, 111 node is called shards. Shards are nothing but the actual nodes which contains the actual data. The query are getting routed through MongoS. Once again, this is a totally production like architecture. Okay. It might not be same as development, and obviously it is pretty difficult for me to cover all these deployment aspects in this particular webinar. But I just want to give you this idea that how it exactly look like in case of a production MongoDB deployment. Okay, then coming to the CRUD introduction, basically MongoDB supports read and write operations. So all those operations are supported. So mainly we can distribute it into two different types of operations: query and data modification. So read operations comes under query, and create, update, delete comes under data modification. This and all we'll see that actually. Okay, now let's start with our actual real example. Okay, so before I do that, let me quickly show you how you actually install MongoDB in your system. It's pretty easy. You go to your MongoDB site and you download the package itself. The moment you download the package, right, you will get that. So if you see, so that can be downloaded into your system and you can extract that. So once you extract that, you will see a bin folder like this. Okay, inside that bin folder you will see lot of distributions, lot of binaries. Now as I have downloaded a Windows version, so I can see all exes. If you are going for your Unix system or your Linux system, then obviously you will see binaries for those operating systems. Now once you have downloaded that, right, you will see one binary called MongoD. So MongoD is nothing but the actual daemon, which is the MongoDB, okay, which runs the MongoDB. This is the actual binary. Okay, so today we will see this one and this one. These two binary we will see today. So MongoD is the actual binary which runs MongoDB, and Mongo is the binary. It will give you a client. Okay, it gives you a Mongo client to talk to your database. Okay, now I'll just quickly see how you start your MongoDB. So after you simply downloaded the zip file for your Windows version, you extract that and you'll go to this bin folder. So my MongoDB was running, so let me stop that first, and then so let's say you have gone to that particular location, you have gone to this bin location first, and what you do to run MongoD, it's pretty easy. You simply type MongoD itself. That should be fine. But if you simply run MongoD, it will look for a default data directory. Default data directory is nothing but /data/db. If you do not mention anything, it will look for a directory called /data/db inside your root directory. So for example, I am running it on this D drive, right? It will look for a directory called /data/db in my D directory. Okay, if you do not have that, then it will fail. To have a custom data directory, what you mention is there is an option called --db path. So let's say for our example, we'll go for a custom data directory. So how you run it? So MongoD space --db path space the directory location. So let's say this is my custom data directory. So the moment I did that, so my process has started. So once my process has started, what I can do is, let me again I have opened one more window, one more command window, and therein I'll type Mongo. The moment I type Mongo, I can connect to the MongoDB. Before that, let me quickly show you one more thing. If you simply run your process, right, the last line says waiting for connection on port 27017. 27017 is the default port where MongoDB runs. Okay, 27017 is the default port where MongoDB runs. So, and there are options how you can point it to a custom port. Those options are there. So let's say I simply connect to MongoDB. The moment I connect to MongoDB, right? So it will directly connect to a database called test. So if you simply type a keyword called DB, it will tell you that which database you have connected to. Now, for example, you want to connect to a different database. I want to connect to a different database called Edureka. What I do use Edureka. Okay. Even before that, let's say you want to see that what are all the databases are present in this particular database. Okay. So what you can do is you can type a command called show DBs. If you do type a command called show DBs, it will list down all the databases which are present in this system. Now let's say I want to connect to a database called Edureka. Okay. So I'll connect to this database, use Edureka. After I connect to this database, you can check out what are all the collections are present. As I said, collections are nothing but tables, right? So you can type show collections, correct? So once I do show collections, it will tell you that how many collections, what are all the collections are there in this particular system, correct? Now, for example, I want to check a quick thing in one of the collection. I want to do a search, okay, for one of the collection. For example, I have a collection called CLS, and I want to check that what are all the records are there in the CLS collection. So what I can do is I can do db.cls. db is the system keyword, and then .cls is the collection name, .find. This means nothing but analogical to RDBMS, select star from class or CLS, whatever. .pretty function I have simply added just to make the result readable. So if you do that, you will see the results which are there in this particular collection. Now, if you see, it talks about some student which are there in this particular class collection. It says underscore ID, name, age, and subject. The one that you are seeing, this is nothing but a JSON object. So far we are talking about document, right? This is nothing but one document. And this is nothing but a JSON, a JavaScript object notation document, which has some 4 fields: underscore ID, name, age, subject. Now, interestingly, you see name, age, name is a string, age is an integer, subject is it's again a string, but there is no definition. There are no DDL query. There is nowhere you define that, okay, my age field should be a different data type, or should be this integer data type. Underscore ID field, as I said, it's a mandated primary key of MongoDB. If you do not mention anything while inserting some data into MongoDB, right? If you do not mention anything on this underscore ID field, by default, it will assign an object ID variable for this underscore ID field. Object ID is nothing but a special type of data type of MongoDB. Okay, it uses processor information, system information, process information, system information, timestamp information, as well as your increment function. Okay, including everything, it comes up with this particular hexadecimal string, and this is nothing but object ID. This is very much useful in terms of a distributed architecture, because there are a lot of systems involved. It might so happen that a lot of system tries to insert a same document, or tries to update the same document, or insert or try to generate particular underscore ID field at the same time. But having said that, we have so many parameters like increment, timestamp, we have process, we have system. It is very difficult to be unique. Okay, so that's how it has been designed. Okay. So that's how we can see how find operation works. Now let's quickly see how I can save a document into this particular collection. Okay. Even before that, what I want to show you a quick query. So for example, I want to see for all those documents for which age is equal to 29. Now, as I said, in MongoDB, everything is a JSON. So whatever value that I am passing inside this find function, right, it is nothing but a JSON object. Age equal to 29. The moment I do that, I'll get some 3 documents. Okay, I'll get some 3 documents. That's how the where criteria works. Okay, now for example, I want to save some document. Okay, I want to insert some document inside this particular collection. How do I do that? To do that, okay, before that, there is one more easy or one more useful function of MongoDB is called find one. So what you can do is you can type find one. Find one will give you always one record. It's similar like, you know, select star from class where limit is equal to 1 or row num is equal to 1, stuff like that. Okay. Now say for example I'm declaring a variable C where I am creating a JSON document. Okay. So JSON document. So for example, name is somebody from my class, Sunil. I can see Sunil is there. So let's say add Sunil. Okay. And let's say age is Sunil. Never mind. I'll just put something. Please don't mind. Okay, if I'm wrong. So then Sunil is reading subject MongoDB. Okay. For example, let's say this is a document I'm declaring in the Mongo shell itself. So C is holding that document, correct? This is nothing but a JSON document. How do you insert? db dot collection name, which is cls dot insert. This is a command, and here you pass that JSON document. So here my JSON document is contained under this C variable, right? So I am passing this C variable. The moment I do that, it says that right result n inserted 1. That means it gives me a acknowledgement back saying that you know, it's already, you know, it's already created. Okay. So now what you can do is, so let's say I want to search this particular record inside this collection. So what I say is name is equal to, let's say, Sunil. Okay, so let's say it is created. Now the moment you see it is created, you will also see there is one more field has got added in terms of underscore ID. Now as I said, this underscore ID is a mandated primary field. If you remember, while inserting the document, we have not mentioned anything in terms of underscore ID. But by default it has been generated. And what is the data type it has been generated? It's a data type called object ID. Okay. Okay, so that's how insert work, that's how find work. And so to delete something from MongoDB, from this collection, right, what we can do is CLS then remove. Okay. So if you do not specify anything and just pass a blank JSON document, it will remove everything. I don't want to remove everything because it's my test data, right? So to remove this Sunil document itself, I'll simply mention where name is equal to Sunil. I'll remove this. So n removed 1. Now if you find Sunil in this particular document, there is no document exist. Okay. So that's how create, update, delete works. There are a lot of other options like query options, okay, like options, okay, you can actually do a count, okay, how many records are there in this particular collection, you can do like this, okay, so there are a lot of other options as well. I'm not going into those details, but before what we want to actually discuss is about a practical use case. Okay. Let's say now we'll see that how we can do data modeling using MongoDB, because you know, people were okay, Rahul is asking, is it auto commit? Yes, Rahul, it is auto commit because we told you, right, because there is no transaction, there is no concept of transaction. The moment you write, it's committed. Okay. Okay, so let's say data model. Okay, so in case of data model, right, can we see actual data in your D drive? Yeah, you can see that, but you know that those are all binary formatted data. Okay, so I'm not going to that detail. First, let me discuss about this. Okay, so data model. Let's say you want to develop an application. You want to develop an application where it's a blogger application, where you maintain all posts created by different users. Okay. Different posts created by different users. For example, In order to do that application, so you have something called post. The post can have fields like title, description, URL, okay, likes, okay, post by, stuff like that, okay. And also you can have comments. Obviously multiple comments can be possible. So if you see this particular diagram, you can have multiple comments, and then you can have tags. So if you see post to tag, you can have 1:many relationship, and post to comments again 1:many relationship. If you want to design this application in using your RDBMS, how will you design? You will design something like this, right? Probably you will need some 3 tables for that. Correct? One table will talk about post, one table will talk about tag, and then you have a foreign key relationship between them, and then one table will talk about comments, which will have post ID, which user is commenting, what is the comment, stuff like that. And then you have a relationship I'm sorry, you have a relationship between the post table and the comments table, a foreign key relationship like that. That means the moment you want to get records for one post, you actually have to have to traverse through all these tables. Correct? Right. So in case of RDBMS, you have to actually traverse 3 tables, 2 joins, 3 tables. Correct? That's what you have to do. If I have to tackle the same use case using MongoDB, what I would have done is I would created a main object, a parent object called post, where I'll maintain all underscore ID, title, description, by, URL, tags, likes, etc. Okay. Now here what I'll do is, as I know that post to tags, it's a 1:10, 1:many relationship, and tag is just having ID and tag. What I'll do is I'll probably maintain an array of tags like this. Okay. And also if you see that I have like 1:many relationship of comments, what I'll do is I'll maintain an array of comments, and comments is again, it's an array of child documents. So if you see this example in the comments itself, right, it's basically another document, another sub document actually, if you see. Correct? So inside that itself, it's another sub document. So that's how probably I will design. This is your one document, and this is your part of one collection. So if you have to get the details of a post, you will go and fetch only one. You will actually traverse only one collection. If you want to save something, you will only touch only one collection. You don't have to go and traverse or touch multiple collections. That's the way you will avoid joins across multiple collections. That's the way you will avoid ACID transactions across multiple collections. You don't have to send multiple queries. Only one query should be fine, right? That's how my data model will be. Okay, now we will see this thing in our applications actually. So what we have done is we are trying to build a Spring applications, Spring MongoDB applications. Let me close this. I'll come to this part. We'll quickly try to show you that how Spring MongoDB works, because it's a pretty very popular tech stack. Okay. So Rajan is saying, are you getting my questions? Please respond. I'm getting your questions, Rajan, but I have not covered everything, right? So that's the reason I am not seeing the questions. Okay, so don't mind, please, because we already kind of reaching our time, but let me cover this first. I'll take your questions, don't worry. Okay, whatever is possible, I'll try to take your questions. So let's say I have created one Maven project. Okay, so in the POM XML, if you see, whoever is having idea about POM, so they will understand pretty quickly. So if you see, right, in the POM XML, okay, Kamesh is saying, to design apps in MongoDB, do we need to know Java? No, that is not needed. I am using Java because it's a popular language. So MongoDB has got driver support for Java, for Python, for Perl, for .NET, for C++, almost all the popular languages. Not only that, these days people are coming up with MongoDB connector. Informatica, very popular ETL tool. Okay, Jasper Report, very popular reporting tool. all of them, they are giving, MongoDB connector. JMeter, a performance tool, LoadRunner, a performance tool, QTP, a performance tool, right? So they have started giving MongoDB connector. I'm not sure about QTP. Okay, so what I'm saying is, and the integration solutions like Mule, like Fuse, JBoss Fuse, right? They have started giving MongoDB connector because of the popularity. Okay, so yes, ab initio is like Informatica, correct. So if you see this dependencies, right, we have Spring dependencies and we have MongoDB dependencies. So we have MongoDB Java driver and we have Spring data. Spring data talks about our all MongoDB feasibility from my Spring. And also I have used a Jackson Mapper API, a Jackson Mapper dependency to deal with my JSON responses. Okay, so what I have done, right? So it's pretty easy thing. So I'll just quickly show you my, sorry, not this one. I'll quickly show you my Spring XML. So if you see this, right? So here what I've done is I've actually created a template, okay, a Mongo template, which is called SSO template. Okay, it takes a constructor called Mongo SSO, which is nothing but containing the DB host and DB port of this particular database. That's how I'm creating the connection. And also it is having the DB name, which database I'm connecting, and the user credentials. So for user credentials, I mentioned the DB user and DB password here. Okay, so that's how I have created the connection. And Mongo template is something which Spring Data gives me, using which I'll do all the database operations. Okay, so I'll just quickly show you what exactly I have done. So I have got one controller to accept my request from my web browser. I have got some domain classes. Let's say for our use case, I have got a class called post, and I have got a class, called comments. Now if you see these two class, right, this is nothing but my data model itself. Okay, so if you see, post is having _ID, title, description, created by, created date, blogs, tags, comments, like this, correct? And tags is nothing but a set of strings, right? And comments is nothing but a list of comments, which is again a variable. So this is again a custom object. If you go there, this is the definition of the comment object, right? It has got user, message, date created, and likes. So two objects we have created from Java. Now if you see, as you know that this is a post, post is the main entity, right? So what we have done is we are using some annotations called @document. This is something again Spring Data gives me, okay, mentioning that collection is equal to post. That means I am mentioning that whatever I want to save from this object is going to get saved in my MongoDB in the post collection. Got it? Like that. And also I have mentioned @ID on top of a field called _ID. That means I am mentioning this _ID field of this Java class will behave as the _ID field of my MongoDB collection. Which collection? This post collection. Okay, like that. These two things I have mentioned. And obviously if you see in the comments class, I have not mentioned anything. So no collection information is mentioned, no ID information is mentioned. So my my goal is to save all these data into one collection as one document, correct? Like that. So that's what my goal is. So what I'm doing is this is a controller class. Okay, so I have some classes. Let me quickly show you. So I have something called let's say I have something called create post. It's a post method. So in this create post method, what I'm doing is I am actually saving this particular information to the database. Okay, so I am expecting some post object from the front end. So this front end can be your web application, can be your interface. You can create Ajax queries from your your JS files itself. But I don't have any UI developed for this particular application. So I will use a post client, correct? I'll use a post client to form this particular request. So let me quickly show you how it will look like. So once you do this, right, create post, it will get saved into your database. For example, I'll use this poster client. So I am actually calling this create post method, and what I'm actually passing it inside, I'm passing it inside, say for example, the way you will create, right, the way you will create inside a particular blogger. Let me remove this comment field first, because I'm for the first time somebody is writing some blog, let's say. Okay, Spring MongoDB integration. Okay, this is my blog name. Okay, description says this blog talks about integration between Spring and MongoDB. It describes CRUD operations using Mongo template. Okay, let's say this is the description. Then this is created by, and this is, let's say, my URL, and let's say I have created a tag called MongoDB and Spring. Okay, so this is what I have created. Now what I'll do, this is a post link, right? So I'll click on post. So it says success, it has been posted. Now what I'll do, I'll go to this Mongo shell, okay, and I'll try to query my post collection. Correct? I'll try to query my post collection. So if you do that, there are other database also, but we also see there is one document created like this. This is what we just added. So we can see title is Spring MongoDB interaction, description, and like this. But for the first time I am creating, so the comment field is blank. The comment field is blank. That's how you create it, right? So now if you see the code of inserting this particular object into database is pretty easy. So if you see here, right, if there are comments, I am doing some I am setting some date for those comments, or also I am setting some date for this actual blog itself, right? But if you see the actual code, is this much, nothing else. So now you see how fast it is. When I am saving it from Java, what I do is I simply use insert command and I simply pass this object, and that's it. I no need to mention like insert into table, then the column name, then the actual values like that. No need to do that. That's it. This is the insert. Okay. So this one line is enough to insert everything in your MongoDB. So this is the object that I'm inserting, correct? Got it, right? So that's how the insert work. Now for example, some update. I want to do some update. What kind of update? I want to add some comment. Somebody is looking into my blog and they want to comment it, for example. Now think on this, we are showing this on the site. We are showing this on the site. So to do that, to show that on the site, what you can do is there is a method called get posts. Okay, get posts. So if you do get posts, it will actually give you all the blogs which are there in descending order. So I'll just quickly show you this, how it looks like. See. So the first block comes which is added last. Why? Because the get post method, not this one, get post is this one, get posts. So the get post method, what it does, it's a find method. So it is calling a function called get post from DB. I'll go there, and there what I'm doing is I'm doing a select star from query with a sorting on this create date field in a descending manner. So that's how you do. That's how you create your query and you send a query to your MongoDB. So if you see here, SSO template.find, I'm passing this query, and this query talks about fetching everything from the database and sorting it in the descending order on the create date field like this. Correct? So this is how you will get it. Now, for example, once you get this guy, now say for example, you want to add some comments. Yeah, this is the last example, and then we'll take questions. Okay. So for example, I want to update the comment of this particular, let's say I want to update this particular, what do you call, Sunil, let's say is want to update, this is a good document, for example. Okay. Initially there won't be any likes, so I will not use any likes. For example, let's say this is what you will do, and you will go here, and the method name is add comment. You will go and post it. It is updated. Now if you go and read this guy, oh, I'm sorry. Now if you see, there is a comments, one comment has been updated inside that particular post. Inside that particular post, there are no likes, so likes is 0. So by default it is 0. Okay, so that's how you can create an application, and you can actually send you can do database operations from your Spring applications. Again, there are a lot of things to be discussed, how how the distribution will happen, how you can achieve security, how you can achieve sharding, okay, stuff like that. So I think this is a good time to take questions, because it's already 10:40. Okay, so let's see what are all the questions you have, one after another. Huh? Don't hurry up, please. So Muhammad Azwar is saying, connection, who access and what happened in that session, information optimization tips for Mongo running mixed production, which factors are need to be considered, you limit. So yeah, these questions are very good questions, Muhammad, but these are pretty descriptive questions to discuss in this webinar, but yes, everything is there. So you have connection options, you can create connection pools. Okay, so there are best practices to create limits. Okay, so references to the Mongo shell scripting. So there are a lot of help commands available in the Mongo shell itself, right? So you can check those things out. Okay, now let's see what are all the other questions. In case of independent entity relationship, Sunil was asking, in case of independent entity relationships, say order and item, how can we see the data model? So now probably you understand that how you can see. Okay, it again depends on the particular use case, correct? Okay, now let's say somebody, Rajan was asking, do we have any GUI for MongoDB? Yes, there are GUI available like RoboMongo, MongoView. So these are some of the GUI you can use to access MongoDB from a user UI interface. Okay, Venkat saying, can we define comments _ID instead of _ID? Comments _ID, no, you cannot. _ID is the mandated primary key, Venkat, so you cannot declare anything else. Okay, Gaja is asking, MongoDB support to SDK, I mean Android applications. Basically yes, but the problem is the programming language, whatever the language, OSXC, whatever you are using, right, you need to check out the driver from there. Generally what happens is, from the Android application you actually access REST services. Okay, you have your server somewhere, okay, and that server is using MongoDB, and it exposes some REST API, correct, and from your Android application you access those things. Mohan is asking, can we get this presentation? Already answered. Okay, Rajan is saying, you said it will return all the data, so it will slow down the performance, right? Actually, no, Rajan, because these are all, TCP level communications, correct? So it will not actually. Okay, Samyak is asking, what is the use of collections? Collections is nothing but, you know, a logical distribution of your data. It's basically a table, correct? In case of RDBMS, you call it table. In case of MongoDB, you call it collections. That's the only thing. Logical grouping of your data, correct? Sunil is asking, primary key is underscore ID. So if we need to insert into DB, do we need to check if the fields say email ID exists and then insert into the DB? No, you don't have to. Say for example, the first document doesn't have a like field, right? But I can actually directly set like field in my Java object and I can directly put it here. I don't have to check that whether the like object exists here or not. That's how the dynamic behavior comes into picture. Dynamic schema comes into picture. Okay, Ram Prasad is asking, is it possible to use MongoDB as in-memory database? It totally depends on in which use case you are using, Ram Prasad. So, for example, you are using as it accesses in memory. Okay, it does a lot of in-memory computation, but it also commits the data to a data file directory which is in disk. Okay, so not only in memory is possible. So that's maybe your answer. Sashank is asking, hi, can we say Oracle RAC will be comparable with all the negatives of SQL? Oracle RAC is kind of yes, but again the challenge is partitioning, because there will be a lot of impacts from your application point of view, but here your application is unimpacted. Venu is asking, what is Mongoose? So Mongoose is it's basically a driver. Okay, it's basically a API which is there for Node.js. Okay, from Node.js to MongoDB there is a connector called Mongoose, library kind of stuff you can think of. Actually they name it as Mongoose. Okay, Rajneesh is asking, what geospatial indexes in MongoDB feature? Yes, MongoDB provides geospatial indexes which helps you to do a lot of coordinate geometry computing. Okay, map computing, location computing, distance computing, stuff like that. In map applications, GPRS applications, you use this kind of features. Okay, can you take up the backup of the DB? Yes, backup and monitoring are there. Satish Gaja is asking, because we use lightweight. Yes, that is right. Ramesh is saying, what was the minimum storage unit for MongoDB? Okay, it's not minimum storage unit, Ramesh. For a 32-bit system, MongoDB has got a limitation of 2 GB for its data directory, but actually there is no minimum limit. But for a 64-bit operating system, there is no limit. Okay, so I think we have taken almost all questions. There are still some more questions are there, but unfortunately due to time, we might not be able to take all the questions. Ramesh is asking, can we use Python instead of Java? Yes, we can. Obviously, we can. Python, we can, obviously. Can we assign our own underscore ID value? Yes, we are actually assigning our own underscore ID value here itself, Venkat. So if you see this particular code, right? So here if you see, we are actually setting underscore IDs as a long value, which is nothing but the current time milliseconds. Okay. Okay. Java code that you just shown, how that integrates to MongoDB. How do we need to deploy the jar of Spring Mongo code on MongoDB? No, actually you don't have to. So basically it's a Java application. Okay, in the background, one of my Jetty application is running. Okay, Jetty container is running actually. Oh, got it? So it's a Java application. From here you are connecting to MongoDB using the Java driver. What real-time application is currently using MongoDB? There are a lot of use cases, Kamesh. So starting from government, starting from financial organization, retailer organization, e-commerce organization, so to building their catalog systems and all. There are a lot of use cases actually. If the partitioning concept exists, how easy to use sharding concepts? It's basically sharding only. When I say sharding, it means partitioning. Okay. Okay, Jay is asking, shall we can use MongoDB in the place of RDBMS in all the cases? That's a very important question, Jay. It all depends on use case. Okay, I'm not saying that MongoDB can replace RDBMS in all the use cases. I am not saying that. There are specific use cases. There are specific non-functional requirements. So it's pretty, difficult to comment that, I simply replace RDBMS with MongoDB. We might not be able to say that. It depends on the use case. Okay, so do we need to learn XML and JSON to learn MongoDB? Not XML, Sashank, but JSON, yes. Okay. So I think, we have covered almost all the questions, and it's already, past almost 20 minutes beyond the time. Ramesh is saying how important to know the dev concepts to become as a MongoDB. Not really, but the query facility, but the query feature you might need to know. Ramesh, but not in that detail. But to become a MongoDBA, you need to know the query facilities. You need to know those basics, right? Okay, I hope that all of you have enjoyed this session. Okay, send your feedbacks as well, and maybe we can quickly end today's session here itself. And I wish all of you a very good day, good night as well for your different time zone, and maybe we can meet in future. If you want to learn MongoDB in detail, contact Edureka and we can take it from there. We have a lot of hands-on, we have practical sessions on each classes, we have certification program as well. I hope you enjoyed it. Okay, thank you everybody. Have a good night and have a good day as well. Bye-bye.